Hello everyone, this is Sumit Sadalgi and uh, I'm currently pursuing my bachelor's degree in computer science and artificial intelligence in Shri Venkateswara College of Engineering. Today's topic is Introduction to the Central Limit Theorem. The Central Limit Theorem is a fundamental concept in the probability and the statistics that has profound implications for the data science. It states that the sampling distribution of the mean of any independent random variable will tend to normal distributions as the sample size increases, regardless of the underlying distribution of the variables. This remarkable property has significant practical implications as it allows us to make robust statistical inferences and draw accurate conclusions from the sample data. So the importance of the central limit theorem in the data science. So the first one is the hypothesis testing, where the central limit theorem enables us to perform the hypothesis testing on a sample means allowing us to draw the conclusions about the population parameters with a known level of the confidence. The second one is the confidence intervals, where by leveraging the normal distribution of a sample means we can construct the reliable confidence intervals to estimate the unknown population parameters. The third one is the predictive modeling. The central limit theorem underpins many predictive modeling techniques such as the linear regression, where the normality assumption is crucial for the statistical inference. The fourth one is the handling large data sets, where as data set size grows, the central limit theorem ensures that the sampling distribution of the mean converges to a normal distribution, simplifying the statistical analysis and the interpretation. So assumptions of the central limit theorem. The first one is the independence. The observation in the sample must be independent of one another. Meaning that the value of one observation does not depend on the value of another. The second one is the finite variance. The random variable being sampled must have finite variance, which ensures that the sampling distribution of the mean will converge to a normal distribution. The third one is the large sample size, where the central limit theorem is more accurate for the large sample sizes, typically requiring a minimum of 30 observations to ensure a good approximation to the normal distribution. So sampling distribution and its properties. The first one is the mean. The mean of the sampling distribution is equal to the population mean, that is regardless of underlying distribution of the random variable. The second one is the variance. The variance of the sampling distribution is equal to the population variance, which is divided by the sample size n. The normality, where as the sample size increases, the sampling distribution of the mean approaches a normal distribution, even if the original distribution is not a non-normal. The practical applications of the central limit theorem. The first application will be in the field of quality control, where the central limit theorem allows us to monitor the quality of the manufacturing processes by analyzing the simply sampling distribution of the product characteristics such as the weight or the diameter. The second application would be in the field of market research, where in the market research, the central limit theorem enables us to estimate the population parameters such as average customer satisfaction or the purchase intent from the sample survey data. The third would be the finance and economics. The central limit theorem is widely used in the finance and economics to model the behavior of the stock returns, exchange rates, and other financial variables. The fourth field is bioinformatics. In the bioinformatics, in the central limit theorem is very crucial for analyzing the gene expression data, where sample sizes are often limited and the underlying distributions may be non-normal. So let's look at some visualization in the central limit theorem. The first one is the random variable, which is the underlying distribution of the random variable being sampled. The second is the sample size, where the number of observation in each sample drawn from the population. The third one is the sampling distribution, where the distribution of a sample means as the sample size increases. And the fourth one is the normal distribution, where the limiting distribution of the sampling distribution as the sample size grows. So let's look at some limitations of the Central limit theorem. The first limitation is the sample size. The central limit theorem requires a sufficient large sample size, typically at least of a 30 observation, to ensure the good approximation to the normal distribution. The second one is the independence, where the observation in the sample must be independent of one another, which may not always be the case in a real world scenarios. And the third one is the finite variance, where the underlying distribution of the random variable variance, which may not be hold a certain heavy tail. So in the conclusion, the key takeaways, the first key takeaway is the powerful theorem that the central limit theorem is indeed a fundamental result in probability and statistics that has a far-reaching implications for the data science and the beyond. And the second one is the robust inference, where by leveraging the normality of the sampling distribution, we can make a robust statistical inferences and the theoretical conclusions from the sample data. The third one is the assumption matter. The central limit theorem relies on a certain assumptions such as the independence and the finite variance, which must be carefully considered when applying the theorem in the practice. And the fourth takeaway is the continuous exploration. Data science facilitates the continuous exploration in the field of uh, central limit theorem and so on. So thank you.